Yeah, hi, good evening to one and all. Once again, I'll be going live today now for the next 45 minutes to 1 hour, where we'll be discussing some very interesting question types from the topic of time, speed, and distance. I'm assuming that everything is working fine. You're able to hear me properly. You're able to see the presentation, and we can straight away get going with our session. If you're attending this live, it would be great if you can just participate parallelly along with me in terms of understanding whether you are able to follow along, applying some of those techniques that we are going to learn while solving questions and responding. The more you respond, the better would be the overall quality of the session in terms of a good learning experience. So um, let's begin our discussion straight away then. So there are three broad categories where we'll be discussing the next set of questions. In the last 9 years or so, from CAT 17 onwards, if you look at the pattern of questions that CAT has thrown from the topic of time, speed, and distance, there is one very clear subcategory that we can identify, which is based on length of race. So typically, linear race is given where there are two people, three people participating in a race. Somebody beats somebody else by certain meters or certain seconds. So there are certain question types that have frequently come. Now, for some of you, it might come as a surprise that some category of questions in CAT are repeated. For people who have already solved previous year questions, you might know this already, but there are certain category of question types that get repeated. The values differ, but overall the pattern remains the same. So there is hardly any difference in the approach that we are expected to follow. And I have picked up a collection of such standard question types, at least from the two broad categories that you see, from length of race and a typical category based on distance from particular home to office or home to a particular railway station, stuff like that. And then we'll pick up certain miscellaneous question types if time permits. There could be other standard question types that could be created. So we'll see how it goes and then take it from there. So let's begin our discussion for the question type which is based on length of race. So if we start with this standard statement that you see in front of your screen, which is in a race, A beats B by P meters, B beats C by Q meters, and A beats R by R meters. Then find the length of the race. I'll want you to give this question 30 seconds to just think of the approach. Don't solve. So we'll solve it together, but I'll just want you to think of the approach that you're going to follow to solve this particular question. How do you think you're expected to solve? How will you calculate this particular length of race? And then we'll solve it together. All right. So now let's try and solve this particular question type, standard question. And then we'll pick up questions based on this very concept that have appeared in previous year's CAT papers. So in a race, if A beats B by P meters, can I say if A covers the length of the race, and let's assume the length of the race to be X meters, if A covers the entire length of race as X meters, then in that same time, can I say B would cover a distance of X minus B? So in, let's say, time t, if A covers a distance of x, then B would cover x minus b, because B will be p meters behind. That is the meaning of this particular sentence, A beats B by p meters. If this is clear, we can follow the same concept for B and C. So if B and C have a race together, B would complete the race because B is beating C, would complete x meters, but C would be somewhere behind. How many meters behind? Q meters behind. So can I say C would be at a distance of x minus q? Similarly, the last statement talks of A beats C by R meters. So we can say that if A covers a distance of x, then C would cover a distance of x minus R. Now look at this particular time. The time t is same for all these values that we have written for distances. Now if I divide distance by time, can I say I'll get speed? So can I say this set of values that I've written x, x minus p, x, x minus q are also the ratio of their speeds? So if I now say that the ratio of speeds of A and B are in the ratio of x and x minus p, that would not be wrong to say. Similarly, I can say ratio of speeds of B and C will be in the ratio of x and x minus q. And similarly, the ratio of speeds of A and C will be in the ratio of x and x minus r. I hope this much is pretty straightforward. Now, if I multiply these two, A by B into B by C, if I multiply A by B into B by C, can I say B and B would get cancelled and I would eventually get A by C? But instead of cancelling, now I'm going to substitute these A by B and B by C values. So if I say A upon B would effectively then become x upon x minus b. B by C from our second expression would become x upon x minus q. And A by C effectively would become x upon x minus r. Now, essentially, we need to find the value of x in terms of the given data PQR. Let's cancel this one x with another x, cross multiply. So we get x into x minus r. This is equal to x minus p multiplied by x minus q. Simple cross multiplication. So should not be too difficult, straightforward. Let's simplify this. Further, we get x square minus xr is equal to x square minus px minus qx plus pq. So I can cancel this x square with x square. I'll take these two terms of px and qx on the left hand side. So if I do that, I get px plus qx minus xr. This then becomes equal to pq. And if I take x common now, my left hand side becomes p plus q minus r is equal to pq. And I get my answer as x is equal to pq upon p plus q minus r. Now this relationship that we have derived, and why is this derivation important? Because then you know the fundamental way to approach such questions. So irrespective of the variety of question type that CAT throws at you, you know that you can talk about the distance covered by the person who wins the race versus the distance covered by the person who is losing the race, and then take ratios from there. So absolutely correct. Ratio of gaps is something that you had suggested, rates, and that is what we have done. But now what I want you to do is put this in your formula notebook. This is probably one of the most useful relationships that you can have in time speed distance, that the length of race is equal to PQ upon P plus Q minus R, where PQ has standard definitions because it's not symmetrical in PQR. Therefore, you'll have to be very careful while memorizing this formula. P refers to the distance that A beats B by. Q is the distance by which B beats C, and R is the distance by which A beats C. Just remember it in this format. A beats B, the parameter is P. B beats C, the parameter is Q. And overall A beats C, the parameter is R. So then if we want to calculate the length of race directly comes from this relationship PQ upon P plus Q minus R. Prachi, I did this via saying that if I say A by B and if I multiply this by B by C, can I say B and B would get cancelled and I would only get this numerator A and this C? So that is what I've written as right hand side. And what is A by B? A by B is nothing but the ratio of speeds of A and B. It could be ratio of distances, ratio of speeds. Ultimately, A upon B into B by C has to be equal to A by C. I hope this is clear. So this we had identified that distance covered by A divided by distance covered by B will be in the ratio x is to x minus b. Distances covered by B and C in same time will be x is to x minus q, and distances covered by A and C will be like this. So what I did, I multiplied A by B with B by C. So B and B would get cancelled. You will get A by C. But rather than cancelling it, we can substitute A by B and B by C with their corresponding values. So we effectively get our relationship. But yeah, hi Supernova, good evening. But the more important part is your ability to remember this relationship. Please make sure that you remember that the value of x is equal to pq upon p plus q minus r. Now we are going to straight away jump to questions that have appeared in CAT, and you just need to remember this one relationship. That's it. You just need to remember this one relationship and you will be able to solve those questions. So let's see. I'm giving you 30 seconds. This is a question, and these are questions from previous year's CAT paper. You can always verify. Some of you might have doubts, sir. CAT doesn't throw such easy questions. CAT doesn't throw repetitive questions. You might have some kind of notions on these lines. You can verify the questions and then see for yourself whether these are genuinely CAT previous year's questions or not. So try this question, 30 seconds max, maybe a minute at best. Once you've understood the relationship that we have built, again I'll rewrite that relationship. Length of race is equal to PQ upon P plus Q minus R. P, Q, R have their standard meanings. P represents the distance by which A beats B, Q represents the distance by which B beats C, and R represents the distance by which A beats C. Right? So tell me the answer once you've tried this, and then again, as usual, we'll solve it together. All right. So let's see the data given in a 10-kilometer race. So we have 10 kilometers of race. So we do already know the length of race. ABC is running at uniform speed, get the gold, silver and bronze. If A beats B by 1 kilometer and B beats C by 1 kilometer, then by how many meters does A beat C? So can I say we already have P and Q? This is P, this is Q. What we need to calculate is R, and we already have the length of race as 10 kilometer. So let us write down the value of length as 10 kilometer. The value of P is 1, so we'll have 1 into value of Q is also 1 upon 1 plus 1 minus R, P plus Q minus R. Let's cross multiply and put 10 on the division side. So if I switch this to left hand side, this becomes 2 minus R is equal to 1 by 10, 1 upon 10. This becomes 2 minus R is equal to 0.1. R becomes equal to 1.9 kilometer. Now the only caution that you need to take care of is to ensure that you answer what is asked. What is asked? What is asked is by how many meters does A beat C? By how many meters? So question uh, is to be read very carefully. 1.9 kilometers is not the answer. They are asking the data in meters. So we'll multiply it by 1000 and say that our answer for the value of R is 1900 meters. I hope this is clear. So this is all. That's it. I mean, my suggestion will be, if this is the first time that you're solving such a question, if this is the first time that you're getting introduced to this relationship, try and memorize this and then solve this question again on your own. Spend time trying to figure out what is P, what is Q, what is R. Get comfortable with this. Once you do it very cleanly, believe me, you will remember this for CAT and beyond. All right. So one question done from CAT 17 slot 2. Excellent, correct answers, Prachi, Supernova, Ritz, all of you. Let's move ahead to the next question. CAT 2019 slot 1. In a race of 3 horses, remember, CAT 17 there was a question, CAT 19 there is a question. Aaron, there is no direct name that I know of. From whatever sources I've seen, I haven't been able to find a source where this formula exists. I would like to believe that this got created automatically, incidentally, if I can use that term, while seeing such a question type and trying to see if we can generalize this. So I discovered it, you can say, incidentally on my own, but there is no name. You can give it any name that you like. So you can say formula for length of race. All right. I'm pretty sure you'll be easily able to solve this question now. Give me the answer for this one. CAT 2019 slot 1. Perfect, Supernova. Correct answer. Rest of you as well. It would be great if you could participate. Share the answers. For those of you who joined late, you can just scroll back and look at the formula. Correct answer rates. Perfect. So let's see. Length of race is simply PQ upon P plus Q minus R. It can't get easier than this, that you've been given all the values and you're just asked the length of race. The only problem is that typically a lot of students tend to go by this method, that if the first one covers X and it beats the second by 11 meters, second one would cover X minus 11. So this will be the distance covered by first, this will be the distance covered by second. All this is good while you're learning, because you should know the fundamental approach, which is what we did at the start by deriving this formula. You should know the ratios approach. But now it's just straightforward. You know the value of P as 11. Remember, this is first beats the third. So this is R, and the value of Q is 80. So essentially you just need to do 11 into 80 divided by 11 plus 80 minus 90. So once you simplify, 11 into 80 is 880 divided by 80 plus 11 is 91 minus 90, which is equal to 1. So final answer, you don't need to do anything else. Just plug in your answer as 880. Fantastic, Spyro. I've got one more participant. Good to see that you've got the answer. One relationship, we have solved two standard questions from previous year's CAT papers in the last 9 years. Nobody can predict that this is something that is going to come in this year's CAT. Nobody knows this. Nobody can predict that in the next 2, 3, 4 years what kind of questions will come. But the best bet that we have is at least making sure that if we are able to develop a command over standard question types that have appeared in CAT, at least if one of those questions from across 10, 12 different topics that we would have done mastery over, if those one or two standard question types come, we'll be able to get the answer within 30 seconds, 45 seconds, under a minute. And believe me, you only need 5 questions net right to clear the sectional cutoff of 85 percentile. 15 marks is all you need in quant. Attempt 5 out of 22, get them all right. So effectively imagine getting those one or two questions right from question types like these, which are pretty standard. You never know from which topic which easier question type will come, and therefore once you do it across topics, it will be a huge booster for you. For those who are looking at higher percentiles, how do you achieve a 99.7, 99.8 in quant section? If you go solving by fundamental method and derivations, you will not be able to secure that 99.7 or 8. You might even get a 99, 99 point, maybe 2, 3, 4, 5, but you'll have to squeeze in time to just look at questions and answer just by making sure of options, taking that calculated risk to edge to that score where you get that high percentile. Let's move ahead to the next question. Another question from CAT 2020 slot 2. Try this out. Get some confidence that what you have studied is repetitive, it is standard, and it doesn't require a whole lot of intelligence to get answers to these questions right. We should get them right in as less a time as possible. Yes, I'll be waiting for your responses. Please do share your answers. Fantastic. I have one more new participant responding, Suki. As usual, Supernova Ritz, you've also shared the answer. Fantastic. So imagine getting one question from previous year's CAT right within few seconds. Saloni, thank you for participating. Fantastic. So that's all. Imagine being able to do this across topics, identifying certain standard question types that are getting repeated, being very sure that if such a question comes, I'm 100% sure that I'll get it right. For a new question, we always study the fundamentals, and classes are there, mock tests are there, a lot of practice that you do back home, sectional tests and stuff like that. But at least you should be 100% sure of certain variety that if a length of race related question comes, I'll be super confident to get this right. So car A beats B by 45 kilometers. I'll directly input this 45 as P. Car B beats C by 50. So this is Q and this is R. So 45 into 50 divided by 45 plus 50 minus 90. So in numerator, let it be 45 into 50. I'm not going to cancel. I'm not going to multiply, rather I'm going to cancel once I get the denominator. 45 plus 50 is 95 minus 90 is 5. I can now cancel this 5 with 10. So 5 tens are 50. I'll get 45 into 10, 450 as my answer. Fantastic, Aaron. Prachi as well. So happy that you people are getting the answers right uh, and getting the answer within seconds. A quick feedback. Do you think this was a concept well understood by you? If yes, we are going to move towards the next concept on similar lines, which is again a standard variety. So once you understand that concept, that how do you proceed, you'll be able to solve questions. They might not be as easy and direct as some of the questions that we see. Nonetheless, they'll be super useful for you to learn. So the second category that we'll take up. So we are done with this first part of length of race. Now we are going to move towards the second category, which is the standard distance from home to office or home to station or home to a certain place, etc. So let's try and understand what this particular question type is all about, and then we'll take it from there. So look at the standard question type. A man leaves his home and walks at a speed of 5 km per hour, reaching the railway station 10 minutes after the train had departed. Alright. If instead he had walked at a speed of 6 km per hour, he would have reached the station 10 minutes before the train's departure. The distance in kilometer from his home to the railway station is. So I'm not going to give you a lot of time to solve. I'm going to explain to you the story, because again, this is a standard question type. Once you understand the story, once you understand the approach, then we'll figure out a way to answer such questions very, very quickly and see the application from CAT previous year's papers. So let's understand the story. Suppose there is a standard time at which the train leaves. So let's say we mark the time for the train's departure, any particular time, random time, I'm assuming. So this is not given in question. I'm assuming that let's say the train departs at 7 a.m. in the morning. So this is the departure time for train. Now when the question says a man leaves his home and walks at a speed of 5 km per hour, reaching the railway station 10 minutes after the train had departed. So the departure time for train that we have assumed is 7 a.m. If the person is reaching 10 minutes after, can I say the person would be reaching at 7:10 a.m.? In the second part of the question story, it says if instead he had walked at 6, which means he's now increasing his speed. So visualize this. On day 1, you live nearby a railway station, you travel at a speed of 5 and you get late by 10 minutes. So obviously to make up for the lost time, you will want to try and increase your speed. So let's say you increase your speed to 6 kilometers per hour. Then you would have reached 10 minutes before the train's departure, which means can I say he would have then reached at 6:50 a.m. If this is the case, this is case 1, day 1, and this is case 2. I'll want you to understand the difference between the time for the two scenarios, case 1 and case 2. Reaching at 7:10 on day 1 and reaching at 6:50 on day 2, can I say there is a clear difference of 20 minutes? Now let me call this via a symbol called as small t and a small subscript as gap. The gap in the time taken for the 2 minutes on day 1 and day 2 were 20 minutes. So T gap is how I like to call it. You should be able to figure out the gap in two scenarios very, very quickly. In this case, the gap in the two scenarios is 20 minutes. Once you've understood the story, 10 minutes later than usual, 10 minutes earlier than usual. So 10 and 10 both will get added up. 20 minutes is the usual time. Suppose 10 minutes later and 5 minutes earlier, then the net difference in time would be 15 minutes. Suppose there is a second case where on the second day he reaches on time. On the first day he is 10 minutes late. So then the difference would just be 10 minutes. You should be able to figure out the value of T gap very, very quickly. This is the first learning that we want to have from this question type. Now, once we've understood this, let's try and map this to try and solve our question. So we know speed into time, the product of them will give us distance. So I'll create a structure. If you have attended my previous session on time and work, you would have seen that we have created a very easy to follow structure of main rate, time and work. Product of MRT gives you the corresponding value for work. Same thing we are doing here. Product of speed and time will give us distance. Initially the speed was 5 kilometers per hour, correct? On day 1, and then he increased his speed to 6 km per hour on day 2. Can I say the distance from his home to the station remains the same? And that is what they are asking, the distance in kilometer from his home to railway station. So can I say the ratio for distances covered would be 1:1? Distance is, let's say, capital D in both cases. So you can cancel D with D and say that the ratio of distances would be same. If the ratio of distances is same, can I say the ratio of time taken will be reciprocal of this? So time taken would be in the ratio of 6:5. This is, remember, a ratio. Now 6 minus 5, can I say the difference of time on the 2 days is 1 in ratio terms? This 1 has no unit so far. This is just 6, this is just 5 as a pure number. 6 minus 5, this is just 1 as a pure number, currently does not have any units. But now we know that the time gap actually was 20 minutes. So can I say this 1 corresponds to a time of 20 minutes actually? So the multiplication factor for the basic ratio will be 20. We can multiply 20 on both the sides and we can say 20 into 6, 120 minutes is the time that you would have taken on day 1 and 100 minutes is the time that you would have taken on day 2 to cover the distance of D, that is the distance from home to railway station. If this much is clear, then we can move towards the final step of calculating the distance. Do we know the speed? Yes, 5 km per hour. So we know that the value of speed is 5 km per hour on day 1. Let's calculate it from day 1. You can calculate it from day 2 as well. And what is the time taken to cover his journey? 120 minutes. So can I say time is 120 minutes? Let's convert this to hours. So we can say this is 2 hours. So distance is nothing but speed into time. So 5 km per hour into 2 hours, distance is simply 10 kilometers. That's our answer. So for this question, the answer is 10. Now this is the derivation or the fundamental way in which you are expected to solve questions of this type once you are dealing with the most fundamental ways used in time speed distance, which is if distance is constant, the ratio of speed will be reciprocal to ratio of time and vice versa. So we said day 1 pe speed was 5, day 2 pe 6. We did the reciprocal, the corresponding value for time came to be 6.5. The difference was 1. The more important part is this 1 corresponds to a value of 20. So understand that this 1 is simply a ratio value. 1 when multiplied with 20 will give us the actual 20 minutes. So we'll multiply 20 as a factor to both this 6 and 5, the ratio terms, and we'll get 120 minutes as the time. Now, given that this is a pretty standard variety, let's create a standard formula out of it. If this much is clear, let's create a standard formula. And why this derivation is important? Because then this will help you remember the formula very, very carefully. And if there are certain variations, you'll be able to play along with those variations in case a new question comes as well. So I'm erasing this part. We have got the answer as 10. Now let's do this derivation to create a direct formula. So we'll say speed into time is distance. Rather than writing speeds as 5 and 6 which were given, let's consider this speed on day 1 as Q and day 2 as P. Let's assume larger of the two speeds to be P. So I'm saying the ratio of speeds or the value of speeds will be Q and P. Distance will be 1:1. So can I say time corresponding to it will be in the ratio PQ. The gap P minus Q The difference will be P minus Q. But remember, this P minus Q is nothing but the gap that we identified as 20 minutes. Remember, this T gap was 20 minutes in this question, but I'm keeping it as a variable T gap itself. So the multiplication factor here will be T gap divided by P minus Q. So this multiplication factor will get multiplied with this P, with this Q. Effectively, the time taken in the first scenario will be P into T gap divided by P minus Q. So this is the corresponding time. This is your speed. Speed into time will give us distance. So I'm directly calculating the distance as speed Q into time. Time is P. T gap, you can simply write it as TG if GAP is too much to write, divided by P minus Q. So if I simplify this further, you can write it in this form: PQ upon P minus Q into T, just simply T or T gap, whichever is convenient to you. Now remember, what is P here? P is the larger of the two speeds. This formula is applicable for the standard question type where a person is traveling on 2 days. On day 1 he travels with a speed of Q, on day 2 he travels with a speed of P. Larger of the two speeds is P because effectively we are going to take the difference of P minus Q in the denominator. So product of the two speeds multiplied by time. Let's apply this direct formula and try and see if we get the answer as 10 kilometer as we got earlier. So we have P and Q as 6 and 5. So we'll have 6 into 5 divided by 6 minus 5 into time gap is 20 minutes. Now remember, we need to convert it to same unit as that of speed. So speeds were in kilometer per hour and this 20 is in minutes. So we need to convert this minute to hour. We'll divide it by 60. That's it. That should give us our answer. 6 minus 5 is any which way is 1. We can cancel this 0 with 0. We can cancel this 6 with 6. Simply 5 into 2 is 10 kilometer as our answer. Now, initially, once you look at this relationship, you will realize that this formula is slightly more difficult. Maybe the fundamental way that we followed earlier was easier. But believe me, once you remember this in exam scenarios, especially when you're under pressure to solve a question quickly, it becomes much easier and you have a lot of time to use this in your mocks, in practice questions that you solve. You will find a lot of questions that will give you situations or scenarios for 2 days. On day 1 a particular person has a speed, day 2 he has a different speed, but the distance is same. And if you want to calculate the distance for those two different speeds, you just need to find the time saved, time gap, and multiply it with PQ upon P minus Q. I'm repeating this relationship, PQ upon P minus Q into time. Just one important message: this has to be in same units as the speed. So if speed is in kilometer per hour, make sure time is in hour. If speed is in meter per second, make sure time is in seconds. If speeds are in per minute, make sure time is in minutes. So make sure that the units are same, which is essentially something that you always should take care of. I hope this is clear. If this is clear, let's try and use the same formula to look at the application of these in some of the interesting questions. CAT 17 slot 1. Try this question on your own. Also tell me the time that you took. Yes, I'll be waiting for your responses. "20 kilometer." Two people simultaneously answered. Suki, Ritz. Fantastic. All right, I'm extremely happy with the response you people have given. You're participating constantly. making it feel like a live session. Nothing better than this. Let's try and see. I'll rewrite the formula for distance. Distance is nothing but PQ upon P minus Q into time gap, whatever be the time difference across the two scenarios of speeds. So what are the speeds? 12 kilometer per hour is one speed, 15 kilometer per hour is another speed. Larger of the two speeds is P, remember. So 15 into 12 divided by 15 minus 12. Now what is the time gap? 10 minutes after the train had departed, 10 minutes before the train's departure. Time gap is 20 minutes. I'll divide it by 60 to convert it to hours. So remember this part. So effectively now we can cancel this 0 with 0, this 2 with 3, and then we can cancel this 3, 15, 5 times. So we get 12 into 5, 60 divided by 15 minus 12 is 3. So 60 by 3, answer comes out to be 20 kilometers. Yes, Suki, it can definitely be solved using uh, taking the distances in terms of 12 kilometer and then taking the time differences, but you'll have to create two equations and then eliminate variables and then solve. So we did that. Once we did the use of ratios, direct relationship is there. Let's make use of it. Let's look at another question. All right. So this is a question from CAT 2020 slot 1. Slight variation in the question type, but basic concept remains the same. Again, take few seconds, try and solve it, share the answer so that I'll be confident that you would now know the approach to get these questions right. All right, so keep fantastic. Got one answer. All right, let's see. Got distance as 10. Fantastic. So let's first calculate the distance. Leaving home at same time, Amal reaches office at 10:15 a.m. if he travels at 8, and at 9:40 a.m. if he travels at 15, which means we know the two speeds as 15 and 8. 15 into 8 divided by 15 minus 8 into time gap. Now just be careful, 10:15 and 9:40. What will be the time gap? It will be 35 minutes. So 35 divided by 60 to convert it to hour. So now 15 minus 8 is 7, correct? So I can cancel this 7 with 35 5 times. I can cancel this 5 with 60 12 times. 12 5s are 60. Further, we can cancel or directly say 15 into 8 is 120 divided by 12. So I can say distance is 10 kilometer. This was the first part. So distance from his home is 10 kilometers to his office. Now they are saying leaving home at 9:10 a.m. At what speed in kilometers per hour must he travel so as to reach office exactly at 10 a.m.? So he has to start at 9:10 and reach at 10 a.m., which means what is the time required for his travel? 50 minutes, 50 minutes. We know the distance, we know the time, we need to calculate speed. Believe me, nothing can get easier than this. That you know the distance, you know the time, you need to calculate speed. That's what time speed distance is all about. Speed is equal to distance traveled per unit time. Distance is 10 kilometer, time is 50 minutes. Let's convert this to hours. So we'll divide it by 60. So upon wala 60 will go on the numerator side. 40 upon 60 goes to the numerator. We can further simplify this. 0 with 0 cancelled. 60 divided by 5. Answer is 12 km per hour. I hope this is clear. And if at all you've committed a mistake in getting the right answer, please identify what was the mistake about. No mistake is a silly mistake. Every mistake will cost you the same in CAT. So if there is a reason that you've got the wrong answer, try and debug it. It was laziness, it was oversight, it was just being casual. What did you get wrong? Make sure that you don't repeat it. Alright, let's move ahead to the next question. CAT 2020 slot 3. Similar question type on distance from home to office. Slightly more different, maybe more time consuming, based on the same pattern. And this is how you build confidence. So I'll wait for just few more seconds and then I'll solve it parallelly along with you. All right, let's look at the solution for this question. Now, if you look at the first part of the question, Vimla starts from office every day at 9 a.m., reaches exactly on time if she drives at her usual speed of 40. She is late by 6 minutes if she drives at 35 km per hour. So just by looking at these first two sentences, we can say this itself could have been one question of the type that we have solved so far. What is the distance from his home to office, for her home to office? So we know this question can be time consuming for those people who don't know a direct shortcut to get the answer for distance in the first sentence. So we know the distance formula. Let's quickly apply it. We have 45 and 30 as the two speeds. So 45 into 30 divided by 45 minus 30 into time gap is 6 minutes converted to hour dividing by 60. So 45 and 30, we can cancel this. 6 tens are 60. We can further have this 0 getting cancelled with this 0, and we can cancel this 5 7 times. So in a matter of few seconds, we know that the distance of Vimla from her home to office is 28 kilometers. I hope this is clear. So at least first part you can get it within seconds once you have developed a good command over the relationship. Now one day she covers 2/3 of her distance to office in 1/3 of her usual time to reach. So let us calculate what is the usual time she takes to reach the office. Usually she drives at 40 km per hour. So I'm calculating T usual time to reach the office. Distance is 28 km and speed is 40 km per hour. Now this is, let's say, in hour. So I'll multiply it by 60 to get this value in minutes. So let's cancel this 0 with 0. Further I can cancel 4 and 28 7 times. So 7 into 6, 42 minutes is the usual time. Now what they're saying in the story is she covers 2/3 of her distance. So 2/3 is taken care of. She has already traveled 2/3. So what needs to be traveled is 1/3 of the distance. So can I write it here that distance that needs to be traveled, let's call it D1. Distance that needs to be traveled further is 1/3, which is 28 by 3 km. This is to be traveled. Just for explanation, the exam, please don't write any such things. This is just for your better understanding. In exam, you don't need to write as less as possible, in fact. So this is the distance that she needs to cover. The speed in which she should drive the remaining distance. So we know the remaining distance to reach office exactly on time. Now, exactly on time, the total time duration required would be 42 minutes, but she has already used up 1/3 of her usual time traveling the two-thirds of the distance. So part of the distance has been traveled in one third of the usual time. So 1 by 3 into 42. This would lead to 14 minutes being taken here. Then she also had a stop for 8 minutes. So let's call this T2, a stop for 8 minutes. So overall time taken so far is equal to this 14 and 8. 22 minutes she has already used up. So out of the usual time that she should reach on time, she has used up 22 minutes. So what is the time remaining for her to reach on time? 42 minus 22, which is what? 20 minutes. Now you just need to calculate speed. Speed is equal to distance upon time. So we'll have 28 divided by 3 upon 20. It is in minutes, so we'll multiply it by 60. So effectively you have 28 by 60 into 60. I've multiplied this 3 with 20. So this becomes 60. 60 with 60 gets cancelled. We get our answer as option 2, 28. Now believe me, this question is very time consuming in general as well. So if somebody had to solve this out of the blue, you would say that easily it should take 2.5, 3 minutes, maybe even more. But if you know the first part, the shortcut to calculate the distance, this will drastically reduce your overall time to maybe 2 minutes or less. So again, my point on, are you trying to get 5 questions right, 6 questions right and get an 85 percentile? Are you trying for 90 to 95 percentile? Are you trying for 98? Whatever be your objective, ultimately it is your ability to solve questions correctly in the least amount of time. Or to put it bluntly, you need ways to get questions right very, very quickly. If you don't have it, irrespective of how strong your foundations are, you will struggle to maximize your attempts and therefore maybe have 7, 8 attempts, 9 attempts, 10 attempts. Majority of CAT aspirants struggle to go beyond 10 attempts if they have good accuracy. Now imagine you being able to do that because you know certain ways. So let's move ahead to the next question. CAT 24 slot 3. CAT 24 slot 3 question based on same type. And I'll tell you exactly how to use a concept that we've studied as a direct formula. You can always create fundamental equations and solve. So please don't have this thought in your head, why aren't we going by standard approaches? I am assuming that you already know standard approaches. I am assuming that you will be able to create equations and solve on your own. So that is always there, and that can always become your go-to way to solve once you know that you don't know a shorter way to solve this. So fundamental way, taking x, taking values and creating equations is always there with you. Try this out. Try and think whether we can apply our formula. 6 km per hour more, 4 hours less, 6 km per hour less, 6 hours more. Can we apply our formula? We are not given two speeds. But can we assume two speeds so that they have a difference of these values? Something like this. All right. Now let me solve this. A train traveled a certain distance at a uniform speed. Let's assume that speed to be x. Had the speed been 6 km per hour more. So can I say the speed was x plus 6? So now I have two speeds. This is my value of q. This is my value of p in the formula pq upon p minus q. And the time gap is 4 hours less, which means the time gap is already given as 4 hours. So can I create an equation for distance using the same standard formula pq upon p minus q into time? So what is pq? We can say x plus 6 into x divided by x plus 6 minus x into time. Time gap is 4 hours. This is a relationship for distance. Can I say similar relationship will be established when the speed is 6 kilometers per hour less? So can I say in this case the larger speed will be x? So x into x minus 6 divided by x minus 6 into time gap here is 6 hours more. So this is 6. That's it. So we can cancel this x with x, cancel this x with x. Effectively, denominator becomes 6. That gets cancelled. We can cancel this x with this x. 4 and 6 can be further cancelled with 2. So 2 2s are 4, 2 3s are 6. If I just multiply, I get 2x plus 12 is equal to 3x minus 18. I hope this is fine. So x is equal to 30. Now this x is what? X is the uniform speed. This is not what they are asking. What they are asking is distance. And this is what we have created the formula for, distance. So just let's put this value of x as 30 in our formula for distance. Any of the two formulas. For the first formula, let's say we take x as 30. So this becomes 36 into 30 divided by the difference between the two speeds is 6 into 4. You can cancel this 6 times. So 36 are 180. 180 into 4, this becomes 720 kilometers. So correct answer for this question will be choice 2. Correct answer, Suki, second option 720. But I'm not very sure whether a lot of people would be able to think from the perspective of using this direct formula for distance, even if they know, because there are no two speeds given, 20 and 30, and then 10 minutes less, 10 minutes more. We are given 4 hours less, 6 hours more. That should be a good hint for us to know that maybe we can think of applying this direct relationship for distance. P and Q we can assume as the two speeds being x and x plus 6 or x and x minus 6. Create two formulas for the same distance, equate them, get the answer for x, put the value of x, get the answer 720. So we have covered a lot of interesting questions based on this concept of distance from home. Now, if we move ahead, we'll be left with miscellaneous type of questions. It's already close to 50 odd minutes now, which is the typical time that we tend to keep for a live session. But compare it with some of the previous sessions that we have had on time and work, average mixed allegation, a session on mathematical reasoning that I took. I think the participation is better now, and we hope to continue the same momentum going ahead as we move closer to CAT. Any suggestions that you have, please, after the session gets over, you can share that in comments. Any feedback, good feedback is always good to hear from the faculty's perspective. So please feel free to share any feedback. And if there is a negative feedback or a criticism or an area of improvement, by all means, feel free to share that as well. So I guess that's it from my side. Thank you so much for being live in this session, and we hope to continue this series of sessions moving ahead as well. All right, I'll take a leave now. Thank you. Thank you, everyone.